Good volume. Am I audible now? Hello?
Yes, sir.
Ma వినిపిస్తుందా?
Yes, sir.
Yes,
Okay. Okay, fine.
sir.
Okay. So I'm sorry for the inconvenience because my input volume has been put in minimum level. That is the reason why you are unable to hear my voice. Anyway, let us continue. Okay, so the biomedical engineer is a person working in research or development in the interface area of medicine and engineering. So he or she will be able to develop the equipment which are used to interface medicine and the engineering. Whereas clinical engineer is a person, he or she is a practitioner working with physicians and patients. Okay, who takes care of the equipment in the hospitals, in the diagnostic centers, okay, and so on. Is a person called as clinical engineer. So the biomedical engineering is an application of engineering to medicine and biology. Second topic, development of biomedical instrumentation, which already has been covered in the previous lecture. So many instruments were developed as early as the 19th century. For example, electrocardiograph was first used by Einthoven at the end of that century. Therefore, Einthoven was considered to be the father of ECG. During the next decade, many instrument manufacturers entered the field of medical instrumentation. But development costs were high, and the medical profession and hospital staff were suspicious of the new equipment and often cooperative. So these are the reasons why there was no rapid development of biomedical instrumentation. It is due to the fact that the cost was high and Staff were suspicious of new technology, new equipment, and so on. Okay. So a large measure of help was provided by US government, in particular by NASA, National Aeronautics and Space Administration. So it has provided funding for the development of biomedical equipments. However, all the major engineering technical societies recognize the need of biomedical engineering in medicine and biology. So thereafter, uh, many societies, technical societies, realized that there was a need of biomedical equipment. Okay, modern equipment, modern tools. Now there is a need developed for courses and curricula in biomedical engineering, and today almost every major university or college has some type of biomedical engineering program. As I told you, almost foreign universities, biomedical engineering is found to be a special branch of engineering, and also in some NITs, so it is found to be a separate branch of engineering. So biometrics is the science of branch of science which includes the measurement of physiological variables and parameters. Okay, so it is a branch of science where the measurement of physiological variables and parameters are included. Biomedical instrumentation provides the tools by which these measurements can be achieved. In order to measure the biomedical parameters or variables, tools are required. So those tools are provided by biomedical instrumentation. The design or specification of medical instrumentation systems. So there are some factors to be considered before developing the biomedical instrument or device. Okay, as we all know, range, first factor is range. Second one, sensitivity, linearity, hysteresis, frequency response, accuracy, signal to noise ratio, stability, isolation, and simplicity. Okay, 10 factors are to be considered before design of any biomedical equipment. Okay, so this is the recap of the previous lecture. Today's lecture begins with man instrument system. Okay. Man and instrument are correlated as a system. Man instrument system is an overall system which includes both the human organism and the instrumentation required for the measurement of human is called man instrument system. In order to perform kind of measurements, okay, through the living system, measuring system is required. Such a system is nothing but man instrument system, wherein electronic components, circuits, transducers, sensors. So all several types of electronic components are involved in the measurement system. Biomedical instrumentation can generally be classified into two major types: clinical and research. Clinical instrumentation is basically devoted to the diagnosis, care, and treatment of patients. It is purely related to hospitals. Okay. Whereas research instrumentation is used to develop the modern biomedical tools, equipments. Okay, based on the requirement of the doctors, based on the requirement of the present day diseases, the diagnostic purposes, researchers would come to know the purpose, and based on the purpose, they would be able to develop the equipment. So measurements in which biomedical instrumentation is employed can be divided into two categories: in vivo and in vitro. An in vivo measurement is one that is made on or within the living organism itself. For example, in order to measure pH of the blood directly, some device has to be inserted into the blood vessel. It has to be cut and device has to be inserted into the bloodstream. So it's a direct measurement. The device is in directly contact with the organ under measurement. Okay. Whereas in vitro measurement is one which is performed outside the body. It's a sometimes non-contact or contact measurement. However, it is performed outside the body. For example, the measurement of this same blood, measurement of pH of the same blood after taking a sample of the blood. Okay, measurement that can be performed through the sample of the blood, not directly in contact with the blood vessel, is nothing but in vitro measurement. Okay, so outside the body. The man is, and as I told you in the previous lecture, sometimes measurements are classified into invasive and non-invasive. Invasive measurement is one which is performed inside the body, whereas non-invasive is nothing but non-contact or outside the body. Okay, please realize the difference of the categories of measurements. Okay, in vivo, in vitro, invasive, and non-invasive. Make a note of the categories of measurements. So the basic objectives of any instrumentation system in general fall into major categories: information gathering, diagnosis, evaluation, monitoring, and control. So the very first phase is to gather the information, to acquire the data. So once the data is acquired or gathered, diagnosis, okay, diagnosis has to be performed, has to be done. Once the diagnosis is finished, evaluation, whether the data is in normal condition or abnormal condition. Okay, so that has to be evaluated. Once evaluation is done, monitoring is required. Patient has to be monitored, has to be put under observation. And if any control is required, so on the last phase, control mechanism is provided such that the patients will be taken utmost care. Okay, so these are the 5 important phases which are very much essential, objectives which are very much essential in any instrumentation system. When it comes to biomedical instrumentation, the data, we take care of the biomedical data. We gather the biomedical, patient data. So, components of man instrument system are the building blocks of man instrumentation system can be seen here. All of you have a look into the block diagram. Okay, so there are different building blocks or components. First one is stimulus, followed by man or woman, or in the context of biomedical instrumentation, the man or woman under measurement is called as subject. So it's a subject. Stimulus followed by subject, and then transducers. There are multiple transducers connected to the subject. You can see there. Okay, so you can ask questions. So why multiple transducers are required at a time? So this to ensure that the blood pressure, body temperature, lung volume. So 2 or more biological parameters, biological variables can be measured at a time. Okay, with the help of multiple transducers. For example, first transducer could be a transducer in order to measure the body temperature. Second transducer could be a blood pressure transducer, and so on. Okay, so depending upon the need, the requirement, we will be able to connect the transducers to this subject. Okay, for the instance, let us say there are 3 transducers. connected to the subject. Okay, so as I said in the offline class, transducer is an electronic device which is capable of converting one form of energy into the other. So in this case, this is able to convert the potentials, electric potentials into electrical output, the biological potentials into electrical output. Okay. So all the outputs of the transducer are connected to the signal conditioning equipment. Next building block is signal conditioning equipment. Okay, so as we all know, signal conditioning equipment is an integrated hybrid circuitry where amplification and shaping of the signal. Okay, many tasks can be performed with the help of signal conditioning equipment. Okay, so in order to modify the signal, in order to convert from AC to DC signal, or in other words, analog to digital signal. So all these no, tasks can be performed with the help of signal conditioning equipment. Okay. So therefore, ultimately, the output of signal conditioning equipment is an amplified signal in this particular context, because biomedical signals are very low signals. They are having low amplitudes and of course low frequencies. So therefore, in order to drive the low amplitude signals and low frequency signals into high amplitudes and high frequencies, signal conditioning module is merely required. Okay, so therefore, the output of signal conditioning equipment is an amplified signal, and there is a display device in order to visualize the signal, maybe temperature, blood pressure, and so on. Okay, and you can see bottom line recording, data processing, and the transmission of data. In order to record the data for future playback. Okay, future playback, recording and the data processing equipment module is required, and also transmission of data is sometimes required. Okay, so within the hospital or half the way of the world, sometimes we will happen to transmit the data. Okay, from our home to the doctor's home. Okay, so therefore, transmission of data is very much important task in the context of biomedical instrumentation. So therefore, in order to transmit the data from one place to the other place, okay, so this module is very much essential. And you can see top position, there is a control feedback module. In order to control the stimulus, stimulus is an external energy provided to the subject in order to energize the organs of the body. Okay, stimulus. So the stimulus must be provided in such a way that it should not harm, it should not ensure any danger to the organs of the body. It should not provide any excess shock to the organs of the body. It must be in a limited range. It must be provided in a limited range, a threshold range to the subject. So therefore, in order to maintain such a threshold value, a control feedback is provided to the stimulus. Okay. This is how the measurement of biological variables from the living organism, maybe man or woman, any animal, happens with this overall system, man instrument system. Okay, so we can see the description of each and every building block here. The subject, as I mentioned, is the human being, sometimes animal, on whom the measurements are made. Stimulus, maybe it could be many forms. Okay, so it could be visual stimulus, flash of light. Okay, auditory, a tone, an audio or voice is sometimes provided to the subject, and it could be tactile stimulus. Tactile means touch, okay, or any direct electrical stimulation is sometimes provided to the subject. So different forms of stimulus are visual, auditory, tactile, and direct electrical stimulation. Transducer is the next block, next component. It is defined as a device capable of converting one form of energy or signal to another. So the transducer may measure temperature, pressure, flow, or any other variables that can be found in the body, but its output is always an electrical signal. You must realize that the output of transducer is always an electrical signal. Okay. Signal conditioning equipment is a system or a module that amplifies, modifies, or in any other way changes the electric output of the transducer is called signal conditioning, sometimes called as signal processing equipment. Next comes display equipment. So the electrical output of the signal conditioning equipment must be converted into a form that can be meaningful for the display. Okay, so which may include a graphic pen recorder that produces a permanent record of data, pen recorder, chart recorder. Okay, recording, data processing, and transmission equipment. It is to record the measured information for possible later use or to transmit it from one location to the another location. Control devices consist of a feedback loop in which part of the output from the signal conditioning or display equipment is used to control the operation of the system in some way. So it is to control the transducers, the stimulus, okay, signal conditioning equipment, and so on. So another topic, problems encountered in measuring a living system. So it is very difficult to measure the variables from the living organism. Okay, during this process, we might encounter many problems, many difficulties in measuring such a living system. So basic problems that can be expected are listed here. There are 8 basic problems that can be expected in attempting measurements from the living system. Number one, inaccessibility of variables to measurement. It is the question of accessibility, where to keep the transducer, what is the exact position where we need to take the measurement is the question mark. Inaccessibility. Okay, there is no standard mark of keeping the transducer upon the organ on which we need the measurement, with which we require the measurement. That is called as inaccessibility of variables to measurement. Suppose we plug in the power supply to any kind of module, there is a standard plug-in socket. We know that we have to keep that particular socket in the plug. But when it comes to the measurement, when it comes to the placement of the transducer into the body or on the body, there is no such a plug-in facility. There is no standard position. So that is nothing but inaccessibility of variables under measurement. For example, you can see here, in some cases, such as in the measurement of dynamic neurochemical activity in the brain, it is very impossible, it is highly difficult to place a suitable transducer in a position to make the measurement. Okay? There is no standard position where we have to keep the transducer. That is nothing but inaccessibility. Variability of data is the second difficulty. Measurements taken under a fixed set of conditions at one time will not necessarily be same as similar measurements made under, it is something like unstable. Measurements are not stable. They may vary from time to time, even for the same input and under the same environmental conditions. They may vary. The data may vary. So therefore, that is the second difficulty in measuring living systems. Okay, measurements taken at 10 o'clock for the same given input with the same transducer and the same conditions may not necessarily be same at 12 p.m. or at 4 p.m. They may vary. Lack of knowledge about interrelationships is another difficulty. Okay, so interrelationships within the body, nobody knows the interrelationships within the body. Even doctors sometimes they might not know the interrelationships within the body. Suppose if they happen to take some measurement within the body, because of lack of knowledge about interrelationships, the physicists or the doctors they might not be able to place the transducer in a right position and to take the exact measurements. That is due to the fact that they are not having knowledge about interrelationships. Okay, and somebody say regarding this particular difficulty, some presentations reveal that it is a lack of relationship between doctor and the clinical engineer. Okay, so that is what is nothing but lack of knowledge about interrelationships, which may ultimately produce inaccuracy. Okay, measurements may not be accurate. There is no lack of knowledge about interrelationships. Interaction among physiological systems is another one, right? So it is the consecutive organs, these subsequent organs may overlap one another sometimes. Okay, if we keep transducer upon one particular organ of the body, sometimes it may interact with the consecutive organ of the body. Okay, which causes some inaccuracy in the measurements. Okay, so interactions among the physiological systems may lead to inaccurate measurements. Hence, therefore, it is found to be a difficulty in measuring the living systems. Okay, the severe is the degree of interaction, the more is the inaccuracy of the measurement. The lesser is the degree of interaction, the higher is the accuracy of the measurement. Because there are many feedback loops involved in the physiological systems. One organ is connected with other organ, and of course they may have some feedback loops. Because of this feedback connections, they might have an interaction among the two or more organs, which will definitely cause some inaccuracy in the measurement. Effect of transducer is another difficulty. Okay, physical presence of the transducer may lead to inaccuracy in the measurement. For example, large flow transducer placed in a bloodstream. If we want to measure the blood flow over the blood that is flowing over the bloodstream, blood vessel, if we cut the blood vessel and we keep the transducer, what happens? We are on our own, ourselves, we are changing the flow of the blood by keeping the transducer before taking the measurements. So that will add, okay, in the measurements, and that the placement of the transducer will definitely cause inaccuracy of the measurement. Okay, it will change the pressure of the blood flow. Okay. So therefore, flow transducer placed in a bloodstream particularly blocks the vessel and changes the pressure flow characteristics of the system. Artifact in the context of biomedical engineering, artifact is nothing but unwanted signal. In our words, noise. It is a noise. Okay, extraneous signal, unwanted signal. So the term refers to any component of a signal that is extraneous to the variable represented by the signal. Okay, it could be a random noise generated within the measuring instrument. Electrical, it could be due to electrical interference. It could be due to crosstalk. and all other unwanted variations that happen in the signal are considered as artifacts. The major source of artifact in the measurement of biological variables is movement of the subject, called as movement artifact. Okay, if the patient is laid on the table, when we connect the sensors or electrodes to the patient, what happens naturally? Patient would be able to move his or her hands or legs. So the movement of the hands or legs will definitely cause some, definitely add unwanted signal in the measurement. Okay, such a inconvenience, such an artifact of noise is nothing but movement artifact. Energy limitations is another one. Energy must be provided, okay, within the limitations. For example, in the block diagram, we have already seen stimulus. Stimulus is provided. So that must be in a limited stimulus. We must be able to uh, provide the limited stimulus. We have to make sure that energy should not go beyond what is required. It should be in a limited range. What happens? It goes beyond. What happens? Damage. It might damage the cells or affect the measurements. So therefore, energy, external energy or the stimulus must be provided within the tolerance band, within the limited band. Safety considerations. There must be safety provided to the patient and to the doctor while taking the measurements. Okay. So hospitals, recent emphasis on hospital safety requires that extra caution must be taken in the design of any measurement. Once a measuring system or instrument is designed, it must ensure the electrical safety to the patient and to the doctor as well. Okay, and hospitals also must be provided with electrical safety measures. Okay, what happens? That is not there. What happens in absence? In its absence, the measurement should not, it should not cause undue pain, trauma, or discomfort unless it becomes necessary to endure these conditions in order to save the patient's life. Okay. So these are the difficulties in measuring any living system. Right? In the next class, we shall see sources of biological potentials, bioelectric potentials, and physiological systems of the body. Okay, such as nervous system, cardiovascular system, and other systems. Okay. So until then, stay safe. Thank you, everyone.